Hello everyone, in this video we will solve this problem. A box having z-axis along its longitudinal dimension while x and y-axis are along the lateral dimension. The strain along the z-axis is 80 times 10 to the power of negative 6 mm per mm. The dimension of the box along the y-axis is 50 mm. Determine the deformation of the y-axis dimension if Poisson's ratio is 0.32. Now, what is asked in the problem is the deformation of the y-axis dimension. And from our module, we have the relationship of, or the formulas that involves the deformation is, we have the strain and its original length. Rearranging this, we'll be able to solve the deformation along the y-axis dimension if we multiply the strain along the y-axis to the original length or the original dimension along the y-axis. We already have Ly, or the original dimension along the y-axis, which is 50 mm. What we need now is the strain along the y-axis. Now we are given with the strain along the z-axis. Okay? We are also given with Poisson's ratio, which is 0.32. And from our module, we have the relationship or the formula for the Poisson's ratio is the strain along the lateral dimension all over the strain along the longitudinal dimension. Okay. Now, if we read in here, z-axis is along the longitudinal dimension. And we are given with the strain along the z-axis. Therefore, the given strain is the longitudinal strain. So this is the longitudinal strain. We also have Poisson's ratio. We'll be able to solve the lateral strain. But what is the lateral strain? X and y axis are along the lateral dimension. Therefore, the lateral strain in here is the same lateral strain here for our y axis. Okay, so solving the lateral axis strain, we will be able to get 0.32 is equal to negative strain along the lateral all over the longitudinal strain, 80 times 10 to the power of negative 6 mm per mm. Okay, so we have the lateral strain is equal to 0.32 times 80 times 10 to the power of negative 6. 0.32 times 80 times 10 to the power of negative 6. You have it here, 2.56. Negative 2.56 times 10 to the power of negative 5 mm per mm. Okay. So we now have the 2.56. We now have the lateral strain. Okay. So this is the same with the strain along the y-axis. So we now have negative 2.56 times 10 to the power of negative 5 times the Ly, which is 50 mm. 50 mm. So we will have the deformation negative 2.56 times 10 to the power of negative 5 times 50. So we have negative 1.28. Okay, 1.28 times 10 to the power of negative 3 mm. Okay, so we have negative 1.28 times 10 to the negative 3. Alright. So this is now the deformation along the y-axis dimension, or the amount of change in length of the y-axis. Now, it is negative, meaning in the longitudinal axis, it increased in size, but the effect on its lateral dimensions, specifically in the y-axis, it decreased in length. That's why it's negative. This is the amount of decrease. Okay.